This lecture is about to find the solution of the system of homogeneous linear equation with a constant coefficient. It is of the form x dash equals to ax, and we termed as equation number 1, where a is the constant and it is usually of n cross n matrix with the real elements, and x dash it is equals to dx over dt. Question number 1, solve the following linear system of equation, and the equation is given of the form dx1 over dt equals to x1 plus x2 and dx2 over dt equals to 4x1 plus x2, where x dash it is equals to ax, and a element a is the matrix n cross n matrix, and these are the coefficients a elements, or the A matrix elements are these coefficients. So here the coefficient is 1. So we write A, the first element of A will be 1. The second element will be 1 also. Second row's first element is 4. And the coefficient of this is 1. So we write here 1 and x1 and x2. And after that, how to find the solution of this is that we suppose that the solution of the given system of equation is of this form: x equals to e into e power lambda t. And in order to find the solution of the given system of equation, we have to solve a minus lambda I into v equals to 0, where lambda is the eigenvalue and v is the corresponding eigenvector. So we have to find the lambda as well as the eigenvector v. Firstly, in order to find these, we have to find the characteristic equation as follows: the determinant of a minus lambda I, it is equals to 0, and the determinant, first we write the determinant, and after that a matrix is equals to 1 1 and 4 1, and minus lambda multiplied by identity matrix, it is 1 0 0 and 1. Then we just multiply lambda with this identity matrix, so it becomes lambda 0 and 0 lambda. After that, we just subtract them both. So 1 minus lambda, we write it over here, 1 minus 0, it will be 1. So the answer is here. 4 minus 0, it will be 4. And 1 minus lambda, it will be as same as it is 1 minus lambda, it is equals to 0. And after that, in order to find the determinant of this, we will just write down in the determinant form and just multiply these diagonal elements, 1 minus lambda multiplied by 1 minus lambda, and minus 4, these diagonal elements minus 4. So when we multiply them, it will be 1 into 1 will be 1, and 1 multiplied by lambda will be minus lambda, and just simplify them, and in the end we will get the answer as lambda square minus 2 lambda minus 3, it is equals to 0. After that, find out the factors of this equation. So in order to find the factors, we are going to have lambda minus c equals to 0, so and lambda plus 1 equals to 0. And after that, the two eigenvalues we get, lambda 1 equals to 3 and lambda 2 equals to minus 1. So these are the two eigenvalues. And now we have to find in the second step eigenvector. The eigenvector corresponding to the first eigenvalue, that is lambda 1 equals to 3. So here we are going to again use this equation, a minus lambda I into v equals to 0, where lambda is 3 now because the first eigenvalue is 3. So we substitute here 3. So it becomes 3 multiplied with this, and this also multiply with the vectors. Vector elements are v1 and v2. And just simplify them, and we get that 1 minus 3 will be equals to minus 2, 1 minus 0 is 1, 4 minus 3, well, 4 minus 0 is 4, and 1 minus 3 it is equals to minus 2, and multiply with these vectors v1 and v2. So simply we get the equation as minus 2 into v1 plus v2 equals to 0. This is one equation. The other equation becomes 4 into v1, so it is 4v1 minus 2 into v2, it is equals to minus 2v2 equals to 0. This is how we are going to write the equation in this is just how we multiply the matrix, two matrices. And after that, we will put them equals to 0. 4v1 minus 2v2 equals to 0. So we take this equation, the second equation, and we find that what is the relation of v1 and v2. When we divide both sides by 2, so we will get 2v1 equals to v2. After that, we suppose and we set that v1 equals to t. So if v1 is t and we substitute here t, v1 equals to t. So 2 multiplied by t, it is equals to v2. So after that, we just find this vector, that vector v, it is equals to v1 and v2. So v1 is t, v2 is 2t. So just take t common. So we will get the vector as 1 and 2. So the eigenvector for the lambda 1 equals to 3 is 1 and 2. After that, we are going to find the eigenvector corresponding to the second eigenvalue, lambda 2 equals to -1. For this also, we will make use of this equation, that lambda a minus lambda I into v. And similarly, we are going to just simplify them, just substitute the value of lambda 2, that is -1. So minus and minus become plus. So just multiply them and simplify them. So we get 1 plus 1 is 2, and 1 minus 0, we get 1. 4 minus plus 0, it is 4, and 1 plus 1 will be equals to 2. Multiply with v, so we get these two equations. 2 into v1 plus v2, it is equals to 0, and 4 into v1 plus 2v2, it is also equals to 0. So 4v1 plus 2v2, it is equals to 0. So just simplify them, and we get 2v1 equals to minus v2. After that, again set v1 equals to t. If we put here v1 equals to t, then v2 will be equals to minus 2t. So v1 is t, suppose, then v2 is minus 2t. So substitute in the vector v. So vector v is v1 and v2. So v1 is t, v2 is minus 2t. So we just get from here and take t as a outside, that is common. So we will get 1 and minus 2 as the second eigenvector. In order to write the solution of the given system of equation, we will have of this form, that x equals to v into e power lambda t. It is also equal to c1 x1 plus c2 x2, where x1 it is equals to of this form. So v1 e power lambda 1 t, and c2 v2 into e power lambda 2 t. So we just substitute the values of v1, v2, lambda 1 and lambda 2. So v1 is 1 and 2, and lambda 1 is 3. So it becomes c1, 1 and 2 e power 3t plus c2. v2 is 1 and minus 2, and lambda 2 is minus 1. So minus t becomes here. So this is how we are going to find the solution of the given system of differential equation. Similarly, the second question is solve the following linear system of equation, and this is the this is the question which is given: dx1 over dt equals to 2x1 minus x2, and dx2 over dt equals to 3x1 minus 2x2. And we have in this form x dash equals to ax, where a is the matrix which will be these coefficient 2, minus 1, 3, minus 2, and x is just x1 and x2. In order to find this also, the solution of this homogeneous linear system, we will have of this form. We suppose that this is the solution: x equals to v into e power lambda t is the solution of the given system of equation. In order to find this, we have to solve this as a minus lambda I into v equals to 0. So we have to find the eigenvalues and the corresponding eigenvectors of a. Firstly, we have to find the lambda, the eigenvalues, that is equals to determinant multiplied by a minus lambda I equals to 0. So here we are going to just find this determinant, and in order to find, just substitute the value, that this is a and this is lambda I is the identity matrix. So just multiply them and we find whatever the roots are. So 2 minus lambda and minus 2 minus lambda, put it like this and multiply this with this, so we get plus 3 equals to 0. So lambda square minus 1 equals to 0. So what will be the value of lambda? It will be equals to lambda square equals to 1 and take its square root. So we get the values plus and minus 1. So these are the two eigenvalues. First eigenvalue is minus 1 and the second value is 1. So the eigenvector corresponding to lambda 1, that is the first eigenvalue, lambda 1 equals to minus 1. So substitute here lambda equals to minus 1. So it becomes plus, and just multiply them and plus them. First we will plus 2 plus 1 is 3, minus 1 plus 0 is 0, minus 1, 3 plus 0 is 3, minus 2 plus 1 will be minus 1. Multiply with this v1 and v2. So we get two equation and that are equals to 3v1 minus v2 and 3v1 minus v2 is equals to 0. So put this any of them, these equation, they are same actually. So put them equals to 0. So we will get 3v1 equals to v2. And we put that set, suppose that v1 is t. If v1 is t, then v2 will be equals to 3t. Now substitute them in the vector v. So we get the required vector v equals to t into 1 and 3. So this is the required eigenvector corresponding to the eigenvalue lambda 1 equals to minus 1. Now we have to find the eigenvector corresponding to the second eigenvalue lambda 2. It is equals to 1. So just substitute again lambda 2 here 1, okay, and then just simplify them. And so when we subtract this 1, 2 minus 1, it will be 1, and minus 1 and minus 0, it will be minus 1. So 3 minus 0, and this becomes minus 2, minus 1 will be minus 3. And multiply with the vector v. So when we multiply, then so we get v1 minus v2 equals to 0 and 3v1 minus 3v2 equals to also 0. So 3v1 minus 3v2 equals to 0. So 3v1 equals to 3v2. So v1 will be equals to v2. Where v1, we set v1 equals to t. And so if v1 is t, so v2 is also t. So after that, we will get the required eigenvector v1, v2 equals to t and t. If we take t as common, so it becomes 1 and 1 here. So the eigenvector for lambda 2 equals to 1. It is 1 and 1. Now in the final step, how to write the solution of the given system of equation. It will be of the form x equals to v into e power lambda t, where v is equals to v is the vector which we have found just now, and lambda are the eigenvalues. So v are the eigenvector. So c1 x1 plus c2 x2. So x1 is nothing but it is equals to v1 into e power lambda 1 t plus c2 into x2. x2 is v2 into e power lambda 2 t, where v1 is 1 and 3 e power minus 1 t plus c2. v2 is also 1 and 1, the eigenvector, and lambda 2 is 1. So this is how we are going to write the final solution for the given system of homogeneous linear system.